Hello and welcome to TechBasement. This is episode 4. Today we've got an exciting agenda around cloud native apps and agile development. I have here my co-host Dean Jackson, and today it's Virtual Dean.
Hey Matt, how you going? It's great to virtually be here. Sorry I couldn't be down in Melbourne today, but with a little bit of innovative technology, I seem to be right here.
Fantastic, so welcome, and we'll introduce our special guest today, Dean. So we have joining us today Simon Elisha, Chief Technology Officer for Pivotal in Australia.
That's right. Thanks, Matt. Thanks for having me, and thanks, Virtual Dean.
No problem. Great to see you, Simon.
And Simon, can you give us a bit of background on your role? What do you do at Pivotal? What's a CTO's role in Australia?
Yeah, so a lot of what I do is spend time with customers, explaining to them what the future can look like, helping them identify ways in which they can build better software and, more importantly, deliver better software in a consistent fashion. And a lot of that then branches out into discussions around continuous integration and microservices and containers and platform and all sorts of other nuance. But if you kind of wind it right back to the core, it's how do I ship better software more frequently?
Cool. So we'll get into that in a moment. Let's get to know you a little bit more though first. So obviously you've got a background in software.
Yeah.
You've worked at Pivotal for?
Nearly 2 years, about a year and a half-ish.
Okay. And how's the journey going?
It's been a whirlwind, that's for sure. It's certainly like being in the middle of a tornado, but It's going great.
And I understand you're also a podcaster. I think I've listened to your podcasts
That's right. The Pivotal Perspectives podcast. Say that 3 times fast. Not nearly as high-tech and sophisticated as the TechBasement. It's more lo-fi than that.
Cool. All right. And Dean, I think you had a question you wanted to ask Simon.
Yeah, so Simon, something we do in the TechBasement here is we ask some personal questions to our guests just to try and get to know them a little better. So I've got 2 questions for you. The first question is, who's your favorite tech leader or visionary in the tech industry and why? And the second one would be, we did this last week on our last episode, being Star Wars is coming out very shortly. Who's your favorite Star Wars character and why?
Wow, two interesting and divergent questions there.
Mm-hmm.
I'll answer the second one first because it's easier. Star Wars character, it's got to be Han Solo. And I'm not going to get into the debate of do you Greedo fire first or not.
Okay.
I'm not going to open that can of worms, but yeah, Han Solo's the man for me. So very much looking forward to, 3 weeks' time?
Yep, countdown's up. I think I saw 11 days.
It's coming up.
I sort of think it was 2 lightsabers. It was 11 days to the release. Yep.
Fantastic. And probably favourite tech leader. It changes from time to time, which I think it changes a good thing. Adrian Cockcroft I'd say is top of my list at the moment. I think what he has done consistently and the vision is brought to the tech community and the openness in which he shares it is admirable.
Cool. All right. Well, let's dive in and explore a bit about what Pivotal's doing. I understand. I think Pivotal's been referred to as the world's largest startup. Could it still be called that?
Kind of, yeah. We're still kind of a startup. I guess we come from a startup heritage, but we have a whole bunch of people working for us, so it's confusing for people. So maybe if I summarise that a little bit. So Pivotal was launched about 2 years ago by Paul Moritz, who people may remember from VMware and Microsoft, done a few visionary things in his time. And it was basically a combination of components that were put together to help build modern software. And part of that was an acquisition, which was a company called Pivotal Labs. And Pivotal Labs has been around since about 1989. And they're at the leading edge of extreme programming, agile, all that good stuff, working with the sort of Silicon Valley elite startups for a long time. And they focused a lot on how to build sustainable, good quality software.
Mm-hmm.
Pivotal was launched and created out of assets from both EMC and VMware. And both EMC and VMware are founding investors in the company.
Mm-hmm.
And there's also a capital investment from General Electric. So they saw what we were doing and said, we want a piece of that. This is the future. And what Pivotal basically does is bring together a lot of assets into one place that were around platform as a service, so Cloud Foundry in particular, and a number of our big data solutions, things like the Greenplum database, Hawk database, Gemfire, Redis, RabbitMQ, a whole bunch of really useful stuff. And the idea is basically to say, well, let's figure out a way to help enterprises build better software more sustainably, launch it somewhere, i.e. on a cloud native platform, run it either consuming and or gathering data as you go, so your big data, fast data, streaming data conversation, and have that naturally feed back into the concept of how you build the software in the first place. You should be feeding it back and have this virtuous cycle going around. So that's sort of what we were built to do, and we were built separately as its own entity because we didn't want to have to sort of be tied to any preconceived way of doing things or a legacy we're trying to protect or anything like that. It's basically go do it the best possible way you can and help others do it.
Yeah. So you talked about cloud native infrastructure, and that's where the word, I think, cloud native apps comes in. What are cloud native apps? Can you explain a bit more about that?
Cloud native apps are really applications built with the realities of today's world and today's technology in mind. So it's basically assuming I can't control how many people are going to use my piece of software. I have no outage windows or downtime anymore. I can't turn it off on the weekend. I need to be launching new versions of my application on a very regular basis, in some cases every 20 minutes, for example. I need to be able to adopt modern technology components, so I can't have this big monolith that is only built one particular way. And I need to be able to deploy it anywhere at any time, be it on premises, in public cloud, in some form of private cloud, some sort of managed hosting provider, what have you. And really the whole cloud native concept is to say, well, how do I deliver software like an Uber does or an Amazon does or a Netflix does, etc.? How do I build it that way? And that's an interesting change that's probably happened over the last 12 months where you remember, particularly with Netflix, everyone talks about Netflix as this, unicorn and no one's actually like that, etc. And now everyone actually realizes actually software's eating the world. We have to be like that. We don't have a choice. So we need to act accordingly and build accordingly.
Yeah.
So Simon, the cloud native apps, I've been reading about, the deployment ideology of the 12-factor, app. How does Pivotal Cloud Foundry sort of support that from the infrastructure layer, in terms of cloud native apps and this 12-factor type ideology? For sure.
So, 12-factor apps is an opinionated way of building applications that emphasizes both stateless application components, but also the storage of state in the right location, configuration techniques that make sense. Basically, a way to build and deploy apps better. But it's kind of hard to take that and just go do it that way. It actually needs to be supported by a platform of some sort, and that's where Cloud Foundry comes into place. So Cloud Foundry is a platform that actually serves two key stakeholders. The one set of stakeholders are developers, and developers are not interested in infrastructure, and I would argue nor should they ever have to be. They want to build their applications and deploy them somewhere and know that they run, they scale, they're available, logging is provided, etc., etc. Yep. Then you've got the operations team who need to manage and run this thing for the long term, and they want to know that they can deploy, manage, and scale and keep things available as well. So Cloud Foundry comes into play because it is opinionated in saying, I expect you to be building 12-factor style apps, and I'll make it easy for you to deploy. And in the demo, we'll show you how easy that is to deploy. It's literally one command to go deploy everything. Yeah. But it also looks after the operator experience to say, well, this has to run somewhere, be it on vCloud Air or Amazon or Azure or on premises. So how do we make that easy and fast and straightforward? We don't have an army of people supporting a platform. We just want it to kind of run itself, and that's where
so last episode we talked about DevOps. So you're talking about developers and operations.
Yeah.
Is Cloud Foundry a way to help accelerate that journey towards?
It's definitely, I call it sort of like the King Arthur's round table of platforms. It basically allows you to bring together developers and operations and have them speaking a consistent language and a coherent language, and to say, here's where our overlaps are, here's the components we're going to work on together, and for the things we don't necessarily want to do exactly the same, something is taking care of that for us. And we're not just trusting that, if I deploy this application, it gets spread across multiple availability zones in this cluster that has auto-scaling switched on. Yeah. I'd rather know that if I do this, it definitely will do that, because you as a platform operator says everything that gets deployed has this happen to it. And what we find is kind of an accelerant in terms of the DevOps journey and experience. One of the big failings I've seen with many companies who are trying to implement DevOps is they say, we want this big organizational structure change and this big cultural change, but guess what? You get to use all the same tools as you used before. Yeah. And you need the three. You need the cultural change, absolutely. You need the structure change, but you've got to give modern tooling as well. No one's trying to do stuff with, old style tooling in a modern style world. It just doesn't work. Doesn't fit.
So in that respect, I guess I've seen another trend, which is organizations trying to shift to this DevOps world, bringing developers and operations together, shift to continuous integration, and realizing that the platforms they're built on are never going to provide the service that they need, and therefore they adopt cloud very quickly. And public cloud instances are evolving. People are saying, when I build my traditional apps, I do that in-house, but when I build a DevOps capability, I'm doing that on public cloud.
Yeah.
A lot of the organizations that I've spoken to are doing that natively on Amazon, Azure, or other cloud services. How does Cloud Foundry come into the mix? Why would I build, because I can build on Cloud Foundry on those platforms, why would I do that rather than natively build on the public cloud?
That's a good question. And it really comes down to openness. So Cloud Foundry is part of the open source community in the form of the Cloud Foundry Foundation. And what this means is you can go and download the open source version of Cloud Foundry and run it. But there are also a number of commercial supported versions of it out there as well. Pivotal Cloud Foundry being one, and biased as I am, I think it's the best one out there. But basically, the idea is to provide a layer of abstraction for developers and operators between the provider that they choose and the platform that they use. So if you think about sort of platform as a service, which is actually probably the earliest incarnation of the as a service services out there, things like Heroku, etc. People jumped onto very quickly and liked because, like, wow, I can just push my code and run it. It's there. The problem with the model as it was first instantiated was that when you made your platform decision, by definition, you made your provider decision. And if I chose Heroku as a platform, I'm choosing them as a provider, which may be great if I'm in North America, not so great if I'm in Australia and they have no presence here. Cloud Foundry abstracts away the platform decision from the provider decision. So I can have a modern cloud-native platform that gives my developers a really good experience, and that's why they use the public cloud. They want a good experience, and a lot of internal IT gives a pretty terrible experience. Cloud Foundry says, hey, let me give you a modern developer-centric experience, but let you choose where you run it, or have a combination of places. So you may say, well, I've got this infrastructure internally, I'm going to run it on VMware or OpenStack, but for some dev test, that's going to be on Amazon or Azure or somewhere else because we've got a good deal, what have you. We just want to flex our capacity. It doesn't matter because it runs the same way, it's managed the same way, it's operated the same way. You're not getting any sort of redundancy in there.
Yep. And an IT... Sorry, Dean, go on.
So Simon, just a quick question, just to elaborate on that a bit. If we look at containers and a lot of these open source technologies that are emerging and other platforms that are more do-it-yourself, what do you see as the type of customer that would choose a full platform like Cloud Foundry, Pivotal Cloud Foundry, a fully managed platform versus sort of build it yourself from scratch? Like, what kind of customer do you see going either way?
Yeah, the way we kind of delineate it is the comparison of a structured platform and an unstructured platform. So Cloud Foundry is by definition a structured platform, and you can think of it as a batteries included type platform. We've made the decisions about how to put together. We've got the container scheduling engine. We orchestrate what's supported. It's basically an out-of-the-box turnkey experience, and it just works. If you want to go the unstructured approach, it means you're building components together. Now, where we see the structured cloud-native platform really resonates is in enterprise. Enterprise just want the modern experience. They don't want the 6 to 12 month project to build a platform. They don't want to have to hire people to maintain the platform because typically those skills are hard to get and hard to keep. And then they also don't want to build a snowflake that's not going to be supported in 6 months, 12 months, 2 years. Now, this is software that's going to run for a long time. Software tends to do that. By having a structured cloud-native platform like Cloud Foundry, it's a product, it's supported, it's secured, it's patched, it's maintained, and all you're doing is downloading and running it rather than having to make any other decisions. You just want to get on and deliver value. The whole premise of having a platform of any type is to say, spend most of your time on the business-related logic and the unique things for your business and none of the undifferentiated heavy lifting. So it makes no sense to say, great, I'm now going to go build a platform like everyone else already has. I should just get one off the shelf and use that and innovate where I should be innovating, which is on my own code.
Okay, so great answer. So enterprise type customers, with all the, expanding, look at what VMware is releasing, Photon for containers, and these new technologies that are really reaching into the enterprise market. Do you see these enterprise customers actually looking at away from public cloud and more towards on-premise as we get more, on-premise infrastructure that really mimics the some of the benefits of a private cloud?
It's definitely a combination that I'm seeing. So I think that the driver for people using their own infrastructure again is being able to provide the modern experience. That's what was lacking. And it's interesting, in past lives I've worked for public cloud providers, etc. And you'd always talk to the developer community, and they always hated internal IT because internal IT was famous for providing pretty crappy infrastructure that was not built the way the developers needed it. They had to do a million change requests. It took 6 weeks to get a firewall port opened up. If you or I were operating in that environment, you'd be frustrated too. You wouldn't be interested. And it took a while for internal IT departments to go, wow, we're actually competing with these other providers. We're not incumbent because we're the only ones who can give you infrastructure anymore. Anyone can give you infrastructure. There's like 20 different providers you can get it from. Yeah. So the way we are going to appeal to our own internal stakeholders is providing a modern, easy, simple experience. And people will use the easiest, best choice. They don't necessarily want to go outside the firewall. They're not going, what am I going to do today? I'm going to use some other provider just to make it difficult for my procurement department. They're like, I've just got to get something done. You guys are in the way, so I'm going to go this way. Whereas what we're seeing now is enterprise IT saying, let me give you an amazing developer experience, which by default means you'll deploy where I would like you to deploy, which helps me have control, helps me have governance, helps me have security, and everyone's happy. We're not having this big argument anymore. And that's where you're seeing people say, well, let's retool and have a proper platform.
One of the things I've found, just having played a bit now with Cloud Foundry, is as an IT organization, you can really give your developers the experience of pushing code to a cloud, whether that cloud runs in your IT, in your data center, out on a public cloud, or across multiple clouds. It kind of abstracts the even knowing where it's built, right? So I guess it gives IT that ability to create that service.
It's that flexibility and that choice, and it's interesting. You see, much to that way that the public cloud providers themselves are aggressively rolling out support for things like Cloud Foundry. So Microsoft just recently announced a limited release of support for Pivotal Cloud Foundry on Azure. They did that off their own back because they saw how many customers want to run this platform. Of course, they would like it to be running on their infrastructure, so they're making it easy. So you're seeing people want to have this choice, this flexibility, this openness.
And traditionally, Microsoft embracing Cloud Foundry is a great thing. Traditionally, Cloud Foundry has been targeted, I think, more at the Java developers, open source. But I've seen there's a bit of a shift in the roadmap and strategy. Yeah,
so certainly its initial incantations, it was very much around open source technologies. So the Linux-based, Ruby, Java, Golang, Python, PHP, all that sort of family. Recently, about 2 months ago, we released Windows and .NET support. So now you can deploy .NET applications on Cloud Foundry, which for many organisations, and I'll speak in a very Australia-New Zealand-centric view, probably half of the enterprises in Australia and New Zealand are .NET shops. Suddenly that's made the benefits of platform available to those people who are developing in .NET. So we now have that Windows support as well.
Yeah, it's interesting. I've just noticed in some of the communities seeing Microsoft shift around what they'll support, getting more open.
Absolutely.
And now we're seeing Apple open sourcing Swift. There's a lot of things happening in traditional vendors providing those tools, going to a more open community.
Yeah, open source, we see that as being table stakes from here on out for software. The days of legacy or proprietary software with heavy burdened license cost, perpetual licensing, etc., it's over. It's done. And to that end, we took all of our software that was previously proprietary, so things like the Green Plum database, which is a massively parallel processing database and data warehouse replacement, things like our Hawk technology, which runs over Hadoop and gives you SQL over Hadoop, Gemfire, our in-memory data grid. So these are significant assets that we've spent 10 years developing. Everything was open source this year. It's all out there in the community. So you can go download it, compile it, use it, contribute. Vibrant communities. It's very exciting because we recognise that customers want to say, I want to make technology choices, but I will not be locked in again. We played that game with the incumbents and we're not playing that game anymore. I'm happy to pay a vendor for support and for providing a curated platform for me or a curated piece of software. But should the day come where I'm not happy with that particular provider, I want the option to either run it myself because it's open source, or have an alternate provider run it for me because it's open source. So I'm in the box seat, I can control it. And I think it's a really healthy thing.
Yeah. Okay. And just moving up the stacker level, beyond the PaaS, but to the developer themselves. So we're seeing a lot of shift in the way people are building applications. We've talked about cloud native apps, but also the shift in the processes and capabilities. And I know Pivotal's recently opened up Pivotal Labs in City to help with that. Could you tell us a bit more about what's that all about and what's happening in that space?
Well, it's interesting. It's really the modernization of the process of building software, as you said, by addressing some of the disciplines that need to be addressed to make software development far more sustainable. So if you've ever worked in traditional software development environments, you'll be familiar with the death march, working late at night, people frantically trying to get stuff done, everyone's unhappy. And so we've sort of had Agile kind of roll through enterprise to some degree. And it ranges from people just putting Kanban boards up on the wall saying, hey, we're Agile, or guess what, we don't have to do documentation anymore, we're Agile. That's kind of not delivering the outcome you want, which is high quality, sustainable code development. So Pivotal Labs is very much, again, opinionated about how we develop code. And so I want to share with you just a few of the sort of high points of Labs, although it's hard to describe it. As you know, Matt, you've been there yourself. You've got to see it for yourself. It's kind of like the Matrix. But we're firm believers in pair programming. So this means two developers sitting at the one machine. They've each got a screen and keyboard, etc., but only one person is driving at one time. And for most people who come from a traditional development background, like, oh my God, I just want to come to work and put my headphones on and code all day. This is a completely different model. This is sitting down together and solving problems. No meetings, no phone calls, no email, no checking Facebook.
No face. I think when I saw Pivotal Labs in the US, the kids were dropping their phones in at the start of the day because they weren't allowed to Facebook. And
you don't. It's really interesting because it is so. Regimented is probably the wrong word, but there's a process. So they come in, they get free breakfast at 8:30, and they say, wow, cool, free breakfast. Well, that's the way you get everyone to come in at the same time. They come, they have a chat, they have breakfast, then they do the stand-up at about 9:07, talk about anything they need to talk about real quick, then they pair up. Now, the first thing that's interesting is you don't pair with the same person every day. So you're swapping all the time. So you can, let's say, Matt, you're really good at Android, and I'm terrible at Android, and we're working on an Android project. I could say, Matt, can I pair with you today because I really want to skill up? And so you'll mentor me. Or then I may know something about Ruby and you want to learn about Ruby and vice versa. So they pair up in the morning, they code till lunchtime. So for a start, that's amazing. Like I'm not checking email, I'm just developing. So you get a lot done. Then they break at lunchtime. You can go to a designated machine and do your email, play ping pong. There's a whole lot of snacks, etc.
When I went in there were kids juggling, watching other people code, but ping pong was going.
Exactly. Then they come back by 1 o'clock, work together again, finish no later than 6 o'clock. 6 o'clock at Labs, everyone's gone home. They don't work on the weekends. It's a marathon, not a sprint. But because you're not context switching, because you're not getting disrupted all the time, the amount that gets done. We had a customer recently who was fully agile, the whole shebang. They went over and did a project in San Fran, and they said they were 5 times more productive than how they worked. So it's just a massive difference.
So was this a customer that was already doing what they termed agile
development? They thought they were at the cutting edge of what you could do with agile. And we took them over and said, let's do pair programming, let's teach you. And that's one of the features of Labs, which I haven't mentioned, is that when we work with customers, we don't say, send us a spec or send us an idea and we'll build it for you. We're not interested in that. Send us your developers, send us your product manager, and we'll do it together. And then you bring that lesson back. So one of the big lessons they will learn is test-driven development. So we have a process which is called red, green, refactor. So red means I write all my test cases first for this particular piece of code I'm building, and they'll all fail because there is no code, but I've written my test cases. Then I write my code to match the test case. So this also means I'm only writing just as much code as I have to meet the test cases, which is, again, often people will waste time building things. They think, oh, I'm going to cater for this really weird case, or I think you just don't need that, so don't build it in the first place. So once you've written that code, the test will run and it'll be green. Then you can look at it again and say, how do I refactor that to be a little more elegant, optimized, what have you? And you go through this process. What this means is, firstly, there's no QA step. QA is built into the process. You've typically got as close to 100% test coverage as you could want. And you've got people who are very confident that the code does what it says on the box. And the test cases are the documentation for the code, because this is what we're trying to get to. It's really effective.
So does Labs train around, then the development side, but the testing and QA processes and tools, or how far does it go? So
we will share all the secret sauce. So everything from how to incept projects in the starting point, how to do the product ideation side of things, how to do the product ownership and product management roles as well, then to what tool sets we happen to use for testing, for development, for construction, how to use the platform, which will be Cloud Foundry naturally, and how to operate and run. So we share everything. So when people leave, often they're so passionate about what they've seen, they'll actually go to their home base and redesign their workspace to look exactly like labs. Because again, everything at labs is done with some thought behind it. So the way the desks are laid out, the space that we use, how the snacks are laid out, it's all thought through for a particular reason. It's not.
Dean, I think I have to remodel the TechBasement.
Yeah, maybe we should take a photo and have that
before and after.
And I was just going to ask, when can we go visit the Sydney labs?
Yeah, so look, definitely if you're interested, visiting labs is a great experience. We've just opened in a temporary space in Sydney, and the formal launch will be early next year, which is really exciting. But we've brought a whole lot of pivots, which is what we call our developers, from various other labs around the world. So people from Toronto, San Francisco, New York, etc., to work out of the Sydney labs to give it that cultural starting point as we hire locally as well and start to grow the team. So it's really exciting.
Yeah. Okay. Cool. So look, we've talked about the platform and the development stage, and I guess when the developers come back, they're gung ho on we want to build on Cloud Foundry, right? That's the core essence of what Pivotal does. I'd love to, rather than talk about it, I'd love to see a bit of a showcase of Cloud Foundry. Do you think you could demonstrate something and
let me whip it up here.
make it a bit more
make it real
visual for everyone?
We can do that. So let me just record my screen here. Alrighty. So what I'm going to showcase for you is a little bit of a demo of just a simple app running on what's called Pivotal Web Services, or PWS as we call it. And this is a sort of publicly hosted version of Cloud Foundry that you can use. There's actually a 60-day free trial for people. And what I'm going to do is log in through the API. And you'll get to see all my mistypings today, because it's always fun to talk and type at the same time. Now
we'll edit it out later.
Yeah, exactly.
Like a professional.
And we're going to test the Wi-Fi of the TechBasement as well. So there is a GUI as well, and I'll show you the GUI shortly. But we're developers here. We've got to start with the command line.
So you've set your target cloud to be a Cloud Foundry.
So I'm pointing to that Cloud Foundry instance. In this case, I've got an organisation called APJ for Australia Pacific, and I'm going to use a development space. So in Cloud Foundry, we have the concept of organisations and spaces, which means you can build a multi-tenanted environment within your organisation. You can slice and dice those however you like. We're not prescriptive about how you do it, but it gives you control over those environments. So I've got a little Ruby application I've created here. And basically the essence of Cloud Foundry from a developer perspective is the ability to what's called push the application. So get it out there, get it into production or into dev or into test, get it running. And the way we make that faster is we have this concept called a manifest. And a manifest allows us to articulate what we want the application to look like. So in this case, my manifest is saying I've got a name, it's going to use 128 meg of RAM in the container. You containerize everything. There's one instance that's going to run, etc. And all I need to do is to just do CF push. And what CF push will do is what I would call a monumental amount of yak shaving. So yak shaving is the useless effort that you go through to actually get to the point that you can do something useful. And so in this case, what it's doing is it's gathering up all my components of my Ruby app, uploading them to the platform. It's then gathering all the dependencies. Now, if you've ever tried to build a machine to run a Ruby app, you'll know it can be a nightmare of dependency hell and installing RVN and a whole lot of tools. I've wasted hours of my life doing this.
Yeah.
And what this is doing right now is it's going to grab all those dependencies for me and create a container. And that container will then include the application and all the versions of everything I need and be ready to be deployed. And then the platform will deploy that container as many times as I've specified. In this case, I've only specified one. And it does that for me. So from a developer perspective, I don't actually have to do anything. It just happens. From an operator perspective, I also don't have to do anything either because it just happens. And it's using what's called a build pack. And the build pack can automatically detect what language you're using and will then build those dependencies in for you. As an operator, I can choose which versions of things I want supported in my build pack. So if a vulnerability is detected in a particular library, I can change my build pack to go to the next version, restage all my applications, and I know everything's running properly.
Right.
This is a really powerful capability because if you consider people who are trying to do it themselves, that's a nightmare process. We've made it an automated process. Now, in the time I've been...
Simon, this stops the, this app only runs on this developer's workstation type scenario.
Exactly. It makes it completely universal. And in the time I've been yammering on, that's run through, and we can go to the URL and visit my fancy application.
Mm-hmm.
Let's go across here. There's the GUI, which we'll tour shortly.
And what you had in the background there was the Pivotal Web Services
That's the Pivotal
GUI.
Web Services GUI. So this is just an app that we've got that will just pull out some metadata that's useful for us at a little test in a moment. Because you'll see we've got this thing called the kill switch here.
Oh, yeah?
That looks fun, doesn't it?
It does.
We'll play with that
I want to
momentarily.
hit that red button.
Definitely, we will. But we'll do a few things first. So this is the console I was mentioning with our applications. And you'll see here it'll show us all the different applications that are running in the space. I share this space with other people, so there's a bunch of stuff running there. But once it refreshes, we'll have a look here. You'll see the application that I just started, which was SE Scale Demo. And you'll see some of the metadata that we collect about the application. We can tell how many instances are running, when it started running, what build pack it's using, any services that it's bound to, and we'll talk about services in a minute, any environment variables that are passed, routes to the internet. Logging is all taken care of by the platform as well, so you can grab all the logs there.
Mm-hmm.
Now, I mentioned binding to services. So we have this concept called the marketplace. And the marketplace is where you can expose different services, you'd like your developers to consume. In this case, we have things like search services, Redis, RabbitMQ, databases, email services, etc. There's a whole bunch. And this is where you give that sort of modern, easy to select experience for your developers to get hold of services. You can choose to internally build for them, not internally build, it's totally up to you.
And you can add to this, right?
You can add, exactly. So you can add commercial ones, you can build your own, you can bind to external services, it's really up to you. We provide ones like RabbitMQ, Redis, etc. A whole bunch. There are third-party ones for things like GitLab and a few logging solutions, and Jenkins is another one. So you can build the whole pipeline on the platform if you want to. Well, what I want to show you for this part of this demo to relate to the kill switch is scaling. So we talk a lot about cloud native apps. One of the features of cloud native apps is they should scale seamlessly and run all the time. Easier said than done for most people. So if we want to scale our application, I can simply say, let's have 5 instances instead of 1 instance running. And I can kick that off, and you'll see that what it does immediately, it says, you've asked me for more instances. I'll go ahead and start some containers. It's all containerized internally, and you'll see how quickly those have started up. So they're up and running. So if we go back to our GUI here and I start to refresh, we'll see that line here, which is marked instance, will start to change as the traffic is round robined.
So Simon, it's pretty awesome that you can, if I've written a 12-factor type app that's stateless, I can scale it out just with the click of a button. What happens if I'm out at the pub and, the streaming content is particularly popular, and I need some more front-end apps? Is there a way to auto-scale this or have it
for sure, yeah. So so you can set up auto-scaling, and that can be based on metric-type rules, so CPU utilization, etc., or it can be based on calendar rules as well. Now, if you've got a big marketing launch happening tonight at 7 o'clock, you'll probably kick your auto-scaling into jump it up at 6:30 and make sure you've got stuff ready to go. So you have complete control over that.
And then you can scale down quite easily,
You can scale down very quickly as well, as simply as you like. So in this case, what we've done is we've built ourselves up to 5 instances. And what I can do as well is I can set it up to show us sort of the resilience of the platform. So what I'm going to do is set up actually what I'm going to do is scale up to 10. So let me just do this quickly. So I'll show you the command line example as well. So again, you can do anything through the API, through the command line, through the GUI, which means a lot of people will bake a lot of this stuff into their pipeline, the development pipeline, and choose. See, because I haven't typed my name properly, just to prove that it's real. Right? So what this is saying is to grow it to 10 instances. And whilst that's happening, what I want to do is set up a little monitoring job here, and we're going to do a watch. -n1. Because what I want to show you is the containers running, and I'm going to start hitting the kill switch. And the kill switch, what the kill switch will do is every time I hit that URL, it's actually going to arbitrarily terminate a container.
Right.
So what I'll be able to show you is the resilience of the application. So here we can see the app is running, and I'm just round robining. There's number 3, number 6, etc.
Yeah.
Now if I hit this kill switch and then I hit it a couple more times, and then we go back to our original thing, you can see the app is still running.
Mm-hmm.
But if we go back over here, was I quick enough to show you it finally? No, I couldn't show you. It spins, it literally goes so
Spins
quick.
up that quickly.
So let me hit the kill switch a few more times, and we'll really kill a bunch.
So we know Netflix has this process called Chaos Monkey. Is this the kill switch is your homegrown?
It's the homegrown Chaos
running
Monkey.
around?
So you can see here, you'll start to see some of the containers failing again if I did it quick enough. Gee, they're really quick. Hang on, let me do it this way. So we actually have something called Chaos Lemur, which actually runs in a similar way to Chaos Monkey on the platform as well. So you can prove that the platform is really resilient. So what I'm going to do is I'm going to do it that way.
Yeah.
See if we can actually see one die. There you go. That was the one that failed. It started up straight away.
Okay.
It's so quick now that it's very hard to see it happening. But essentially what I'm showing there is the fact that you can build a resilient application where what used to be, oh my goodness, the application's down, run for the hills, everyone on a call, etc., becomes a situation of self-healing, where you actually don't have to do anything except look at the logs later on and go, oh, look, the app failed 16 times last night. Maybe there was some pretty crappy code we put in that's causing some sort of memory leak. Let's go ahead and resolve that. But the actual application from the customer's perspective is still working really fine.
Yeah, got it. That's pretty cool. So and this is when we talk about stateless apps and stateless containers. This is an example of that because failing the app doesn't, or the container doesn't bring down the application.
Exactly. It doesn't affect anything. And that's why when we talk about the stateful components, they're stored in things like in-memory data grids or relational databases or NoSQL databases, which are provided through that marketplace and are also run by the platform. So the platform will automatically spin up a clustered, replicated, backed up MySQL database, for example. So to bring that sucker down, there's a lot that's going to have to go wrong. So it's just done for you. You're not having to architect it.
Fantastic. Great demo. Thank you, Simon. Appreciate you coming in today.
Pleasure.
Dean, anything else before we start to wrap up?
No, that was an awesome demo.
Thank you. So look, I guess the one thing on my mind is there'll be infrastructure people, architects out there who are thinking, wow, this is cool. I want to get relevant in this world of containers, cloud native applications and so forth. What would you say? Where's the best place to start? How would somebody go about it if they're learning about this world, trying to understand how the architecture applications are changing, what that means for infrastructure? Yeah. What you've got some advice you could give our audience?
Yeah, for sure. So the first thing would be visit pivotal.io and read the website because there's a lot of information there about what cloud native apps are, etc. Mm-hmm. We also provide obviously the podcast, which gives you a lot of information as well. But the biggest advice I can give to our listeners and viewers is to go ahead and do it. So jump onto Pivotal Web Services, for example, and push an application. It's very easy to get any application from GitHub and just see what it's like, see what you do. The people who make the transition, and if I speak significantly to infrastructure folks who I've dealt with for a long time, by walking in the shoes of the developer, you actually start to understand what they're on about and what they need. Yeah. So it's a case of not saying, well, how do I build the next Amazon? It's a case of saying, well, what do developers actually do day to day, and how can I make their lives easier? And trying it and go, that's what they mean by I don't want to wait 6 weeks for a firewall change. And that gets you going.
Cool. All right, look, Simon, thank you very much. Thanks to my co-host, Virtual Dean Jackson.
Thanks, Matt, and thank you, Simon. It's been awesome, and again, really cool demo. It's awesome stuff.
Yeah, appreciate you coming in.
Thank you.
Thank you.